All right, we have another force example. This one we're going to try to find mass. So example number 2, Marty decided to move the cabinet in his dining room. Marty stood on one side and pushed left with a force of 30 newtons of force, although there was 10 newtons of force of friction. If the cabinet accelerates at 0.34 meters per second left, what is its mass? So first thing, again, decide if this is balanced or unbalanced. Because we have an acceleration, it's going to be unbalanced, so we got to draw our free body diagram. Okay, so we have our force of gravity acting on the cabinet and our normal force. Again, these two are equal. We don't know the value of those as of right now, so and we don't need to for this particular problem. Now, we are pushing to the left, so my applied force is going to be towards the left. And we actually do know what this is, and this is actually 30 newtons. So we're going to put that there. And then we have a force of friction, which they gave us, and that is going to the right. It's opposing my motion, and that is only 10 newtons. Okay, again, this is an unbalanced diagram because my force applied is greater than my force of friction, and which gives me a positive acceleration. So now let's figure out what I have. All right, so they give me in the problem my acceleration, and my acceleration is positive 0.34 meters per second squared to the left. And then they give me enough information for my net force. I just have to calculate it. Okay, I know my normal and my force of gravity. Those are going to cancel out. So I'm left with my horizontal force. If my force applied is 30 newtons and my force of friction is 10, I have 20 newtons greater to this side, so my net force is 20 newtons to the left. Okay. Again, force is a vector quantity, so we not only need magnitude, but we need a direction. So then I'm left with what I'm missing, and that's my mass. So we know, based on Newton's second law, F net equals mass times acceleration. What I want to do is use my circle that I've used in previous examples, not specifically for this, but I'm going to put F net up here and my mass and my acceleration here. Anything that's together is going to be multiplied. Anything right here is going to be divided. So if I want to manipulate my equation beforehand, I'm going to cover up what I want to know. That's mass. So I'm left with F net divided by acceleration equals mass. So I'm going to rewrite that. Mass equals F net divided by acceleration. So now all I have to do is plug in the information that I have. So again, my mass, my net force is 20 newtons left. My acceleration is 0.34 meters per second squared left. If I plug these two magnitudes into my calculator, I should get out a mass of 58.82 kilograms. And again, mass is going to be in kilograms, and that should be consistent with all of our masses in Newton's second law. And after that, I have all of my information, and there is my answer.